Just to give you a quick introduction. So Axelta is an IoT company founded in 2013 by two IITians. As part of this company, a number of things are being offered. Um, One is in the area of training. So boot camps are being conducted for IoT analytics, and there are also corporate and retail training that's covered. In terms of the solutions, consulting and product delivery, a couple of products being supported. So there's a cloud-based environment based on which we're able to provide remote sales, security, and logistics. Just a very quick preview uh, to highlight who we are. So we have been providing, as part of this, two important uh, lines of training. One is core IoT. The other one is how to apply analytics in the world of IoT, which is the context of what we would be looking at today. So in terms of what is IoT, which is Internet of Things, and today people say Internet of everything. It's an amalgamation of technology where there are devices, sensors, data being generated. They are being consumed, collected, and it has been processed and analyzed, based on which some decisions are being taken. A very simple, simplified view of Internet of Things. Now, Internet of Things, as the name suggests, it could be everything. Um, a sensor could be a temperature sensor. It could be a light sensor. It need not even be a sensor. It can even be an instrument that is connected to your car onboard diagnostics port. It could be any measuring devices, engineering or otherwise. It could also be your internet, which is also a valuable source of information, where we are trying to do a meaningful interpretation of it. A lot of applications have been talked about. Some of them are in various stages of implementation. Things like smart cities, smart health, on environment, on water conservation, logistic, industrial automation, insurance, vehicle, your self-driving cars. In number of areas they are being applied. What we would see today is the general construct of analytics in the IoT world. There are three simple questions that I will ask, and then we will proceed with that. Is before we look at IoT analytics or analytics within the IoT context, there are three definitions. What is analytics? Is IoT part of analytics, or is analytics part of IoT? The answer to question number 2 and 3 is essentially both can be right, and we will look at some examples of both. But what exactly is analytics? In very simple terms, a data analytics is a consulting process where you start off with a business requirement. You identify a set of, a business requirement could be in terms of what is the sales of a restaurant, or if an accident happens, what is the expected claims that the insurance company has to pay out. It could be the alcohol level in blood. It could be a value like that. And what we are trying to do here is what is contributing to that variable. And we do an hypothesis of identifying what are the contributing variables, identify them, process them, and really understand which of those variables are making an impact on your target variable. With that, we are able to go back to the business and answer their original question: how exactly is their sales impacted? Now that's analytics. An Internet of Things, does it fit into analytics? Now you can do an analytics project where a sensor or a device can be part of the life cycle, or you might be considering implementation of an overall IoT solution where the focus is more on technology and enablement, where analytics can play a role as part of it. So both are acceptable processes. It really depends what is the starting point of your business requirement. What is analytics? There are two definitions. It's quite nice, and we can talk through that. Uh, the first definition is, if you torture the data long enough, it will confess. It's as if that you are torturing a criminal for details on a crime that you are investigating, and if you torture them long enough, finally they may confess. In the world of analytics, again, when you are looking at a specific business requirement and business challenge, you don't really know where the answer is going to come from. So what you really do is you look at the data in multiple angles, keep asking n number of insight questions, almost similar to the way that you ask a criminal or you investigate a criminal. You kind of ask different kind of insight questions, and sooner or later there will be some insight questions which will help you identify the answer that you're looking for. The second definition, which is also interesting, is all models are wrong, some are useful. So I've not even introduced the analytical model at this juncture, but analytical model is nothing but a simple logic which will allow you to draw conclusions about a target variable. And most of the models, or almost all of the models, are approximation techniques. So they tend to be wrong. They are different from the reality. But some are closer to the reality than others. So some models are more useful. So we'll talk through what model is, how do you torture the data, and how do we go about doing the entire process. Some examples of pure play analytics is, let's talk about a retail industry. It could be an online e-commerce site, or it could be a retailer which is selling merchandise. Now they would like to understand who are the most profitable customers. And then with that, they want to understand how they can position products and promotional offers. So I know you are all coming from different countries. Now you do have come across loyalty programs. For instance, Tesco in UK has a loyalty program where the coupons are printed when you are making purchases. So if you have a loyalty card, they produce coupons at the time of purchase, which will allow you to encash them, or rather encash them, or offset them against future purchases. Now the coupons has to be relevant to you. Now if you are a vegetarian and you are given a coupon for a meat or a fish, you're not going to be happy with it. So you want something that, based on your prior purchases, on the kind of items that you are purchasing, you want the coupon so you have the opportunity to actually utilize them in the same shop. Now from a retailer perspective, that 20 cents 30 cents kind of a discount on a product such as milk will ensure that you actually come to that shop. Now when you are coming to a shop, you don't come for one item. Even though you have one item in your mind, you actually tend to buy 10 other items. So that discount that is provided on one item, which is enticing a customer to come to the shop, actually enables a higher level of revenue, because obviously the customer is going to buy more items. Now before you give this coupon, so you understand how a coupon is enabling you to retain your customers and not to lose them to another shop. At the same time, you will have to make the coupon as relevant as possible to this customer. So you need to do an analysis on what are the prior purchase pattern. Now you need to look at customers who are purchasing frequently. You need to understand their frequency of purchase in terms of the monetary value that they are spending, the recency of purchase. We call that as RFM analysis in marketing term: recency, frequency, monetary. So how recent is this customer? How frequently is this customer purchasing? And what is the overall monetary value? And accordingly, you can structure the discounts. A similar equation would be on an online retailer. You will get a lot of campaign emails on products that are being launched. Now, one of their success rate for the companies to evaluate whether their marketing is successful or not is the click-through rate. They want to understand how many customers are actually clicking on a particular advertisement and who are not, and who is proceeding all the way to a product purchase. Now, for you to ensure you don't want to send too many campaign emails to a customer if the customer is going to ignore most of the emails. You probably want to make it as relevant as possible. Send them a smaller set where there is a higher probability that the customer will actually click on it, view the ad, and that makes your campaign an effective one. This is again another example of how you apply analytics. Now, this doesn't seem to include uh, an IoT context, but then as we go along, we will look at a couple of other examples where we will look at a traditional analytics, how it is being applied, and how an Internet of Thing or a sensor comes in and augments your traditional analytical process to give a more superior view of your customer. Just before I proceed, I just wanted to take a quick check. Is my voice audible? Am I going at the right pace? Are you able to follow this so far? Excellent. Thank you. All right. So let's look at a very, very quick example. Now, in an Indian context, this is extremely or quite recent, as in it was released as recent as September of last year. But in a UK or US context, I think it has been there for a couple of years now. What we are looking at is a very simple use case uh, of a insurance company. This is a general insurance company. Okay, sorry, a general insurance company where they would want to use telematics to reward customers based on their good driving behavior. Let's take this a little bit clearer. I know there's a lot of text on this particular slide. I'll just take a very simple example of US or Indian context. Now, if you are looking at buying a new uh, insurance for your vehicle, there are broadly two or three things that are being asked from a customer. The first thing that they ask is, what is your driving license number? Now, with that number, the insurance companies will be able to look up from the Department of Motor Vehicle and identify what is your driving history. Have you had any accidents in the past? Have you had any traffic violations in the past? The past could be 2 years, it could be 6 months, it could be anywhere between 6 months to 2 years.
Muted.
Okay, sorry guys. I think there was a bit of a blip in the connectivity, so I guess I'm back now. Are you able to see the screen now? Thank you. Excellent. Sorry about that. Okay, so coming back to this, there are a couple of questions that an insurance company asks a person when they have a when they are applying for an insurance policy. So the first thing is the driving history, so which is covered in terms of understanding what is your driving history in terms of did you have any accidents or tickets in the past. It could be anywhere from 6 months to 2 years. They also with that they can also identify the age of the driver in terms of the experience. Okay. um, I just got a message from Cat that you're not able to hear me. Is that the case? Are you guys able to hear me now? Okay. All right. Thanks. So the second aspect of it is the vehicle VIN number. With that, you can identify the vehicle's history itself. So that will give you an idea about the quality of the vehicle, the age of the vehicle, and the insurability aspect of it. So essentially, if you are claiming, if you are having insuring a car, let's say for $20,000, the car has to be worth that amount. So insurance company will not insure a car more than what it is worth. It's not profitable for them, right? So, and the third information that they typically ask from you is, what is the typical distance that you drive per day? Okay. Now it seemed like a seemingly innocent question. The key thing here is, if you are driving lot of kilometers every day, and if you are living quite away from your office, so it means that you are going to spend more time on the road. More time on the road, it means that more chance that your vehicle will go through an accident. So that is their interpretation. So the idea is that not only is your driving history, not only is your vehicle history, but also the expected usage of the vehicle based on the information that you are providing, an insurance company tries to give a quote. Okay. Now we all use aggregator sites. We all go to a website like Policy Bazaar or Go Compare kind of sites, where we will go and just say, okay, here is my car, here is my license number, give me the best quote. So what has happened? The aggregators are getting the quotes from different companies and then providing to the customer in one simple view. What has happened is different companies have different risk appetite. Okay, because the way that they can reduce the premium for you is basically there. It is a reflection of their risk appetite. Are they ready to take the risk at a lower premium or not? Now, what is becoming is, it's becoming a price game, literally. Insurance companies can't keep infinitely reducing their premium amount without incurring cost, because if there is an accident, they are going to pay out that money. So it will result in significant loss for them. So what they want to do now, here is the business requirement that is coming up. An insurance company wants to know, is there a way of me reducing the premium for customers without impacting the risk profile? Okay, so this is a simple, important business question that we ask. So is there a way of reducing the premium? I don't want to reduce the premium for all my customers, but is there a way I can give a different premium structure for customers who are driving better than others? A very simple, fundamental business question. How do I find that out? Now here is where your telematics solution comes into play. Okay, so there are some questions that the insurance company is asking. Can we understand the customer driving pattern? Okay, so if there is a good driver, is there a way of me doing this? Can I engage a way of constantly, can I have a way of constantly engaging with drivers to ensure that they continue to drive good? Okay, and make them drive safe. So those are the kind of questions that we want to ask. But how will I find that out? Now what you're seeing on the screen, I don't know if it is visible, there are a couple of screenshots. The screenshot in the middle, what you're seeing here, let me just get the ink here. What you're seeing in the middle is a very simple implementation of a telematics device. So basically, this is a device that you can buy. It's available. It's not too expensive as well, which plugs into the onboard diagnostics port of a car. All new cars, especially I think 1980s onwards, or in Indian context 2000 onwards, all of them, they come with this port. This device, what it does is it measures the instrumentations of the engine. So it looks at O2 indicator, it looks at the how much you have pressed the brake pedal, how much you have pressed the accelerator pedal, the XYZ, the gyroscope. It looks at the current speed of the vehicle. It looks at number of things, and then it extracts that. Okay, so this device has the capability. What you do is you build an app. Okay, a sample app is provided here. Now with this app connects to this device through a Bluetooth connectivity, and it pings the device. Okay, so you can set it up every minute, every second. I want to find out what's going on, and then it extracts the information, and the information can be easily extracted into a CSV format. Now an insurance company may not take this route, but a similar route, because obviously the control of the device, the control of the app is with you as a driver. So you might be faking the data in some sense. You don't want to do that, so they will have a more hardwired scenario, but a very simple or equivalent implementation of this. What you're seeing at the bottom is a simple Excel extract. I don't think you can read it, but I'll just read it out for you. You can collect information like the timestamp in which the measurement was taken, and that could be at every seconds level or even every half a second level. The GPS coordinates, which presumably comes from the app, not from the device, which is your latitude and longitude. The speed of the car at the time of measurement. Okay. Now these 3 to 4 columns are more than sufficient, and you can do a number of things with that. For example, if you know the GPS coordinates and if you know the timestamp, one of the things that you can figure out is this driver, does that person drive during the daytime or the nighttime typically? So if you're looking at 6 months of data with the timestamp, you will be able to figure out at what time does this person typically drive. So that gives you a sense of a driver. You know, people who typically drive between 12 midnight and 4 in the morning, you're probably going to be a little worried, because that's the time when we are extremely sleepy. So even if you're not drunk, that's going to be a bit of a issue. Now, how many hard brakes do you make? Okay, so you're going at 60 miles per hour, and all of a second, next second, your speed actually drops, let's say to 30 or 20. So you measure it. How many times does this person press a hard brake like this? Okay, hard brake is not a regular brake where you are stopping for a signal, but really, how do you, when you are actually applying a brake because there is a danger and hazard in front of you. So how many hard brakes does this person make per month, per week? You ask any of these questions, you will have an answer to that. With the GPS coordinates, you can also measure the distance that the person travels on a daily basis, on a weekly basis, on a monthly basis. Assuming that you are able to collect this information for a 3 months horizon, okay, as a bare minimum, with that you can try to get a sense of what is the driving pattern of this individual. Now there are 3 important things. Your driving history is already taken into account, your vehicle history already taken into account, but your 3 months of your driving pattern is taken into account. Now there is a big difference between the driving pattern in a US to a UK to a Europe to an Indian to an African context. Okay, now you can apply specific rules for the respective country. Okay, in India, if you're looking at it, that 60 miles is usually is happening on a highway. People don't go at 60 miles within the city. The speed limit is typically in the range of 40 kilometers per hour. So people tend to travel anywhere from 60 to 80 kilometers per hour. However, in a highway, they do significantly faster. So you can apply context at a city level, at an interstate level, at a country level. I think this is from a solutioning perspective. If you are thinking of this, these are the considerations that you'll have to take into account. Okay. Now, if you are really looking at this particular example, there is a telematic device, which is your IoT sensor. There is an app. The information can get loaded into some database. It could be a big data or a regular database. But the point about even plugging in a sensor is driven by a business requirement where you are trying to answer these insight questions. Okay, so these are the insight questions. You are trying to go deep dive. These are high level questions. You are really getting into the deeper level of questions. What exactly is this driving pattern? What is the way people are driving? So again, in an Indian context, you guys can even think about The amount of an impatient driver is indicated by the amount of honking the person does on a car or a bike. Okay, that's a very clear indication of a. So you don't need a telematic device like this. You probably need a microphone of some sort to measure that. I think it's really up to us to determine what we want to do. But the overall story is that there is a shortcoming from a business perspective. There is a clear requirement. With that, we identified a data source, which is basically a telematic device based data source. We have a very clear set of insight requirements that we are trying to answer. Now, for each of these questions, is this question that can be answered by the device, or does it have to come from an alternate source? So you think through all of that, implement the solution, then you do your analytical processing. Okay, when I'm analytical processing, there are essentially number of steps that we will have to follow. Typically, a data analytics starts with a business problem. We have just seen that example, and it is defined at a very high level, and it is usually at a very vague level. Okay, so the statement could be, I want to improve sales, I want to reduce the premium for good drivers. That's it, very high level. Now we will have to break it down. We will have to break it down into lot of insight questions. What defines a good driver in an Indian context? Is this person making less than 5 hard breaks per week? Is that constitute a good driver, or is it 10, or is it 2, or is it nil? Okay, so we ask these kind of questions. Then we ask further questions. What is making a driver a bad driver? Okay, a lot of times, even if you are driving normally in a road, the moment somebody is trying to overtake you or pass you, the adrenaline goes up. Okay, so obviously there is a road rage. There is a psychological effect to it. So is there an influence of other bad drivers having an impact on you as a driver? That could be one question. Is the quality of road, is that an impact to a bad driving pattern? Okay, now you can ask a lot of these questions. Is the number of signals, okay, the maturity of the drivers there, is that a place which is metropolitan in nature? Is that a village? Is it a town? Okay, now what kind of educational institutes are there? How many people have gone to abroad, understood different driving pattern, and then come back to India, for example? Could be another thing, right? So what we are trying to understand is, what is making a driver a good driver or a bad driver? You're trying to understand the contributing factors, which is step number 1. Okay, step number 2 is, with these contributing factors, you form what is known as a hypothesis. So your hypothesis could be, bad road conditions lead to bad drivers. Okay, the alternate can also be true. Bad conditions, people typically tend to drive slower, so they are more safer when compared against a nice road where people tend to accelerate significantly faster. Okay, so it could also be the alternative here. So our hypothesis is nothing but an assumption. We are thinking that maybe this is contributing to this. Once we have identified that, we try to collect the data that is going to help us answer these questions. I think there is a question. I'll answer it in a minute. Once you identify these data that is going to help you answer those specific insight questions, you then apply data analytical techniques. When you look at data analytical techniques, there are actually 4 stages, and I'll answer the question from Devesh in terms of machine learning. Where does that fit in? So you will come across a lot of terminologies like machine learning, artificial intelligence, data science, business analytics, data analytics, I think I'm repeating artificial intelligence, deep learning, neural network, random forest, XGBoost, supervised learning, prescriptive analytics. People tend to throw a lot of these terminologies around. There are a lot of overlapping concepts. Okay, so if you want to have a very simplified view, call the end-to-end ecosystem as a space of data science. Okay, data science is inclusive of trying to do a post-mortem analysis of explaining what has happened in the past, but also you can use the same thing to predict what is going to happen in the future. You can prescribe what exactly we should be doing in future. Okay, one of the thing that fits into that are two techniques, or rather, if you, okay, let me just go through the stages. When you're doing data analysis on the data, trying to understand the correlation to your target objective, which is your sales or good driver behavior, all of that, you tend to go through these four processes. The first one is a simple data exploration. Now, if I ask a very simple question, how long does it take from your office to your house? Immediately, you might throw up a number like 1 hour, 45 minutes, 2 hours, 3 hours. Now, if I ask you a question, how exactly did you come out with that? You might say, I've been going to the same office for the last couple of years. Okay, so if you have been there, if you're going to your office for 2 years, so and let's say that you went to the office 240 days in a given year, you went and you came back. So 240 into 480 per year, maybe 2 years, 960. What we are essentially looking at, we are looking at 960 observations. Granted, you have not documented it anywhere. Maybe you have mentally documented it. With that, you have just taken an arithmetic mean average of all of that, and you are just going to say it's going to be about 45 minutes. Okay, let's say that you go to a new location. You were there for about a week. Let's say day one you took 40 minutes, day two it took 50 minutes, day three it took about 60, day four 70, day eight 90 minutes. It's all over the place. So if I ask you for an average, you might still come back and say, you know what, on an average it's about 50 minutes, but you know what, there is a variance significant. Some days it is taking so less, some days it is taking too high. It really depends what time of the day I'm leaving and things like that. Okay, when you are talking in very natural sense, these kind of concepts, statistically what you are applying is the concept of mean, concept of median, concept of variance, concept of standard deviation, plus or minus, all of that. So statistically there are number of techniques to look at the data. And this I think, if you are in the IT field, you will be building a lot of tables, your reports, charts and all of that to explain what's going on with your project. They are essentially your first two boxes that you're seeing on the screen, which is data exploration and visualization. Now, visualization, we have historically, we tend to do bar charts and pie charts because they are visually appealing. You want to do something, but there is a purpose for each of these charts, and there are significantly more. Visualization is a technique that should be used to help you put together the story. It is not a report that you generate for someone else, but it is a report that you generate for yourself. Then the advanced analytical topic, which is supervised and unsupervised. This is where the machine learning also comes into play. Okay, so when you're talking about the analytical technique, sometimes there is a target variable like good driver or bad driver, or it could be the amount somebody pays out in claims. It goes into one of these two techniques, either a regression technique or a classification technique. So you have a specific questions, there is an interest variable, there is a target variable. You're trying to do all your analysis around this target variable. That technique is called supervised learning. There's a second type of learning called unsupervised. A simple example is what I've given here. It's not an exhaustive list. It's a very simple example, clustering. So for example, clustering is nothing but a pattern recognition or a customer segmentation technique. Take the same example. Let's take customers that your data that you have collected. You have collected age. Let's say you collected height, and let's say from a sensor you have collected the number of steps a person walks per day. So you have age, your height, your number of steps. Let's say that you want to sell products like a walking shoe, a basketball shoe, maybe a protein mix, maybe a Gatorade kind of an energy drink. There are a number of products. You don't want to sell it to all your customers. So what you want to do? You want to group the customers together. Okay, you want to identify, is there a way I can group the customers such that, and see if there is a natural grouping. So your natural grouping could be, hey, I see three groups of customers. Group one of customers have an average age of 20. So, they are youngsters. They walk about 3,000 steps a day. Okay, they are couch potatoes with a height of something. Okay, couch potatoes, young guys, what can we do to make them more active? Okay, then there could be another group, middle-aged guys who walk about 5,000 steps. You know what? Sell them some protein mix or something like that. Senior citizens on the other end, Maybe they're walking 7,000 steps or they're walking 2,000 steps. You know what, let's get them comfortable shoes, so that it is less painful on their knees, right? Let's have an acupuncture kind of a shoes. So for you to sell these kind of products, you need to understand what is the natural grouping within the data. There is no target variable. You just want to find out, here is the large volume of data. I'm just trying to see, is there a natural grouping of the people itself? A technique like clustering will come into play. So if you're looking at, these are the 4 analytical stages. Any business problem that you take where you're applying an IoT, collecting data. Finally, when you process the data, when you do the analysis, it goes into these 4 steps. The first 2 are almost mandatory. The third and the fourth can be a combination of things that we would do. For the same business problem, you might try one with regression, you might try one with clustering, because they are 2 separate insight questions. But so it can be optional, but the first 2 steps are almost mandatory. Okay, so these are the various steps from a data analytics perspective. So again, Devesh, I hope I answered your question. When you talk about machine learning, now a machine trying to come out with its own model, the model could be a regression model or it could be a classification model. So your machine learning typically fits into your typically the supervised analytical techniques. Occasionally you will see some unsupervised techniques also where machine learning is used. Now there are statistical approaches, there are machine learning. We are expecting the machine to learn on its own. Machine doesn't do anything like that. Essentially, you either rebuild the model. A model is nothing but a logic. When you talk about a regression or a classification model, in very simple terms, what it is trying to tell you is, if a person makes 4 heartbreaks per week and the person drives at least 20 kilometers in the night between 12 midnight and 4 in the morning, this person is a bad driver. Okay, so there are independent input variables contributing to a target variable, which is a bad driver or not. So when you structure questions like that, it actually tries to build the model. Let's say you get data of completely new region. Let's say you build this for maybe the state of Maryland. Let's say you got data for South Carolina or San Francisco. You keep adding to it. Then you will have to rebuild the model. Now I have fresh set of data. Are there state specific characteristics on the driving habit? Okay. So some of my friends who have driven 15 kilometers or 15 miles above the speed limit in San Francisco, because that is the norm there, have paid fines when they drove in South Carolina, where typically people don't go above 5 miles over the speed limit, right? So I think there are state specific requirements that you'll have to apply as part of this. So your logic, your model, which is nothing but the logic, can change as you add more data, and it will become more and more robust. Okay, so these are the multiple steps in your analytical model. If you have to go through a little bit more detail from an analytics or your project delivery, you start off with the business requirements. I think we have covered the hypothesis questions. You look at the data, you collect the data, you clean it up and transformation. Believe me, any project that you take, this particular step, maybe I will include this, can be anywhere from 80 to 90% of your project effort. Significantly high impact. Okay, it can go as high as 80 to 90. I'm not saying that every single project you will have 80 to 90%. It can go as high as 80 to 90% of your overall project effort is not on analytical modeling. It is on data cleanup. Your entire project can go for a toss. So with that caution, please ensure that if you are in an IoT journey, you are looking at Internet of Things, you want to deal with sensors, devices, and all of that. Please ensure that you always make a correlation to the target objective of the business problem, what it is that you're trying to solve. Ensure that the data that is going to be coming from the devices is going to be accurate. It is going to be clean. It won't be clean. You will have to spend some time on cleaning up, which is also fine. But as long as you have a good handle on the data, then your model accuracy will go up. Okay. People tend to talk about neural network, support vector machine. They'll talk about all those jazzy terms, but and there are different techniques of doing regression, different techniques of doing classification. But remember, if you guys have seen an older radio, you will see a main tuner and then there is a fine tuner. Okay, so the main tuner gets you closer to that frequency. The fine tuner does a very fine tuning which is hovering around this particular frequency, right? So the main tuning gets you closer to the answer. The fine tuning is basically refining the answer in terms of your model accuracy. Any analytical model that you take, you talk about neural network, you talk about support vector machine, or very simplistic logistic regression kind of a model, the model accuracy improves based on the quality of data, the right kind of data, the right features of data, the right variables bringing into the model. Okay, neural network doesn't automatically give you the highest accuracy. It really depends on the data. If you get good quality data, most of the models tend to perform within the same level of accuracy. There are obviously some models which will give you a higher level of accuracy. Okay, so let me just go back. I think there is one question from Sangal. Can you talk about some platforms or big companies working in the domain of IoT analytics as a core, from manufacturing sensors to acquiring data? I'm a little bit confused where the domain is. Are you looking for a manufacturing company as an example, or are you looking at a platform, or are you looking at an IoT solution or specifically IoT analytics? Um, Sorry, Sankalp, I'm not clear on that question. If you can. Big companies working in the domain of, or are you looking at companies making these products, or are you looking at companies implementing these solutions? There are two different things. Okay, so I think you conveniently said both. All right, so let me talk through what I can answer. Obviously, my exposure to the IoT hardware industry is limited because I'm more focused on the IoT analytics aspect of it. So, if you look at insurance companies like Progressive, uh, they are already implementing, or they have already implemented this usage-based insurance. The example that we just saw so far, where there is an equivalent example of this, is what I have built here. And they have a little bit more sophisticated model of doing that, but essentially the concept would look similar. There will be a data collection device, except that you cannot tamper with it. Okay, so it is almost fixed. If you remove the device, obviously it will send that information to the insurance company that the device was removed. It could be done. Okay, now let's talk about another company which is actually trying evaluating something, which again I'll give you one more example from insurance, then I'll try to switch over to other industries as well. So insurance, obviously, it's a one of the most boring financial institutes historically, but they are the industry which is really exploiting this IoT as a concept to the maximum. Now, State Farm Insurance is actually putting together a model for distracted driver. So what they want to do is, they don't want to just look at the hard brakes that you're doing. They want to actually have a camera and take a photo of you in case there is an accident. They want to look at that photo split second prior to your accident, and they want to automatically predict based on the photo. There were 10 classes, 10 different scenarios. Number one, you are actually driving the car safely. Number two, you are actually talking on the phone with your right hand. Number three, with your left hand. Number four, you are actually texting. Number five, you are actually turning back, talking to your co-passenger, or turning right to your co-passenger. Then you are drinking coffee. You are changing the radio or adjusting the stereo or something like that. There's 10 different classes. So they are applying image analytics to do this. So the sensor would require a camera, and the camera to convert that image into pixel, the pixel into some data point, and then there will be an algorithm, which was the whole point of the competition. They have announced that as part of the Kaggle, which is an online competition site. As part of that, they actually were looking for models which will give you a very high accuracy of whether which kind of distraction the driver was going through when the accident happened. So that model is being trained and it has been built based on about worth of 4 GB worth of simulated data. So they put the car on top of a truck, and they took, a guy was drinking coffee and all of that. So he was not actually driving, but the way the photographs were taken, it looked like he was actually driving. So in a very safe simulated environment, they did take the photograph. With that, they built the model. So the model was built with 4 GB worth of data, and there will be some 10 classifications. So they have some 1,000 images where the guy or girl is drinking coffee with the right hand. Another 1,000 images where the person was drinking coffee or something else with their left hand. So on and so forth. With that, the model was trained, and it was built, and then they were looking at testing the model with some new data which nobody knows what is the right answer. So I am aware of one more insurance company, but on the image analytics space. Now let's look at manufacturing. Now your entire inventory management, temperature management, for example. So let's take inventory management. So there is a warehouse. The data, any product completed or raw material goes from one factory to another. What happens is when the vehicles in which it is taken, lot of pilferage happen, right? The vehicle stops on a location where they are not supposed to stop, and then some of the components goes missing, and depends on various types of products that are being transferred. So there is a solution. If let's say it is a meat or a vegetable, it's a perishable goods, where the temperature is being measured. So the moment somebody opens the truck door, obviously the temperature will see a spike, small size spike. So if you are constantly measuring it, there is an opportunity for you to determine, okay, at this juncture, why did the temperature really go up? Was the truck stopped at that particular point in time? With that, you can make an educated guess that this particular truck was stopped when the doors were opened. Okay, so this is some use cases of where IoT. So obviously, all your your terrorism face recognition that is used by a government agency in airports and all of that, they are pretty standard stuff. Now in terms of platforms, okay, what kind of platforms? I think it's really up to us to determine. I think it goes on a case to case basis. Now a solution like what we have seen, and I'm just popping that up on the screen. A simple end-to-end use case kind of thing. So your telematics data will come either in a CSV format, or which you can upload, or it can be a real-time interface to your server through a web service. So you send it as a JSON format. Now let's take that in a very simple example. If you have a big data platform, so you might have information coming in. So understanding the big data platform, you have multiple ways of which data can be consumed into the system. You have the Flume, which is the older one. We have the Apache Spark. You have the Spark streaming. You have NiFi, which is the most latest. You have Storm, and you have multiple ways of data coming into your system, depending on what kind of data you want to bring it. Then that data is stored in a repository of some sort. Okay. Now, whether you want a big data environment or your regular server can handle it, I think that is on a case to case basis. You need to really look at the platform requirement. A telematics data is probably not that big, honestly speaking. Even if you are looking at 1 million cars, and let's say you are collecting data at every seconds level, but the number of columns that you are going to collect will not be significantly high. It can be 4 different columns. So the number of rows might be high, but in terms of volume or size, it can be compressed. And over a period of time, you can compress the data, make it more meaningful rather than having the raw data itself. So there are ways of managing it. Then when you the raw data is needs to become converted into some meaningful format where you might use a pig or a hive kind of a transformation to summarize the data, make it simpler. And so again, the example that I given here is an Azure platform. Azure also has a machine learning platform where you can plug in the data directly to a machine learning studio where you can build the models. Now, if you want to build models around ML connecting to a big data source, you can do literally end to end. Okay, so these are some of the use cases that we have come across. Okay, I hope my volume was okay. You are able to hear me. Okay. Just a quick recap. There's one slide where I talked about data sources, which is very critical because from an analytics perspective, we are interested in the data sources. There are potentially 5 different sources in some sense. When you look at data, the first one is internal data. So when before you jump into any IoT solution, first look at the business problem and understand, is there data available already in my systems that can answer what the people are asking for? Okay, so 50 to 60% of data for data analytics comes from your internal data, which is already there. You don't have to do anything more. If you don't have that, then you try to source it from an external source. Now, do you want to really collect it yourself, or would you rather try to get the experience? For example, I guess it was Arity, which is one of the startups started by Allstate Insurance. It was a startup for usage-based insurance. Okay. Now the startup, they are spinning it off such that they want the startup to go and support other insurance companies also. So they have wealth of analytical models. They will know the driving pattern state by state based on one insurance company's example. So you can, as an insurance company, you can simply go and purchase the data. You don't really need to collect it. So if the information is already available, all the TRP ratings for your TV, they all come from AC Nielsen's kind of companies. So who actually does this data collection? So you simply purchase from them. If the data is not available, then you try to go and secure new, where you can do 3 processes. Number 1, survey. Number 2, observed data. Number 3, generated through experimental design or experimental study. The observed data is predominantly where bulk of your sensors come in. So a temperature sensor is really a data observation collection point, right? A traffic pattern at an intersection is being used. Survey is more of employee satisfaction, customer satisfaction, where you are actively asking humans to respond back to survey. Observation is basically the mechanized way of collecting data without actually asking any questions. Sometimes you also generate data through clinical trials, for example, where there is a treatment and control group and you want to look at the effectiveness of a new drug. So you actually, through experimental design, you actually collect some data. Social media sentiments or some of the examples from a IoT context. So I kind of went slightly tangential, but I'm just coming back to the slide and wanted to focus purely on this data identification. Where your IoT fits in is predominantly in the observed data category. So this is where your wearable devices will also come into play. Now, from a healthcare industry, I think going back to the question that was asked earlier, a lot of times around all right, so let me complete this. I think there is from a healthcare industry, doctors are leveraging the wearable devices for continuous patient monitoring after operations or surgery is completed. A lot of focus in the healthcare industry. Image analytics predominantly used in your cancer detection and disease detection, which are conventional ways are not giving enough sufficient results. They want to do an early detection by looking at cancerous cells. They want to clearly articulate that. So healthcare industry is very big into IoT and sensors. Now, I'm sure a lot of startups are now working on what is known as a fall indicator. So they want to put a device, especially for the old age people. So they have their life and they stand, they walk, they live their life. But suddenly if they have fallen down, they want this device to automatically dial 911 or call the ambulance of some sort or or call someone else so somebody can come and check. So they want to ensure that it's not somebody actually is lying down to sleep or the person has actually fallen down. How do you predict it? How do you check that out? This is another area where significant number of startups are involved in this. There are already solutions that are being used in this place. So the next question is, how can we run real-time analytics on the fly and provide the analysis from time to time? Is there a framework available to provide uh, to 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 do real-time analytics? Okay, so a lot of times when people start with analytics, what is the starting point on analytics? Everyone thinks about data, or many people think about data, which is a wrong thing to do. You always start off with a business requirement. Okay, I know it's almost a cliche statement. I've already mentioned this 10 times, but please do remember, when you go into engagements, people will say, here is some data, can you start doing an analysis and come back with some analytical reports? That's typically how things people start. Please don't fall into the trap, because without a goalpost, it's very difficult to understand what kind of analysis that you are doing here. Okay, so let's take a very simple example where a real-time analytics will be useful. Okay, a movie industry, the entertainment industry is very critical that way. Sai Krishna, so to answer your question, now if there is a movie or if there is a negative image, it can really go viral. Okay, so there is a context of us trying to manage that scenario. So you can't prevent certain things. If a movie is taken, it's already taken. There's not much you can do about it, right? uh, but let's take the example of Barclays. For example, it's a bank in UK. So they rolled out a product, and the product allowed customers to send money to people using only the mobile number. Okay, this was a couple of years ago. Now, what happened was, they were measuring they were looking at the social media to look at what is the feedback of the customers, and they immediately found there was one negative scenario there coming up, where the customers were not able to send money to their kids who were 17 years old or something like that. They had a rule of somebody has to be a minimum years of 18 as an adult to transfer money, and unfortunately the 17-year-old kid were not getting money, and parents were trying to send their allowances to their kids, and they found that that was counter productive. So within 2 weeks or so, Barclays rolled out another version of the app that fixed that problem. I think they lowered the age because it was giving a lot of negative sentiment, and then with that they are able to manage that scenario. Okay, now that would be, I would say, is a real-time analytics. But then there was a context to checking. There was a product launch, and there was a conscious decision to look at, is there any feedback coming out of this? Now let's take the example of a manufacturing industry where there is a you want to ensure that there is no fire accidents or a fire accident is prevented. So you install a temperature sensor, okay, at specific points. You might have temperature sensor, let's say, in 10 different points. Some of them are close to machinery, some of them are close to an AC point, some of them are or just right in the middle of something. So what you do here is, you look at every temperature sensor and you collect data over a period of time. Okay, so you look at weekdays, you look at weekends, and you try to put together a pattern. We call that time series analysis, where we look at typically what is the trend and seasonality of the temperature read by this particular sensor. So it could be that normally it reads about 35 to 40, but 8 o'clock in the morning every single day it goes up to 42 and then comes down. Maybe there is a normal for some strange reason. Okay, if that is the normal for that particular sensor, then what you do is you start baselining that. Okay, and let's say on one particular day the temperature drops to 25 degrees Celsius for whatever reason. That is an anomaly from a particular sensor perspective. So once you have collected the data over a period of time, you set a benchmark, and beyond that benchmark you trigger an action or an insight question. So that's how a real-time analytics will be done. Without a context, you can't simply say, okay, I'm doing this analysis, suddenly something is going up or down. There are instrumentation that gives you output, but how do you interpret? Is 45 degrees Celsius, is that an anomaly for this temperature sensor or not? It may be, but for another device which is closer to a machinery, 45 degrees may not be a anomaly. It's still a normal business as usual scenario. So this is the context that you have to apply, and a requirement like I want to ensure that if the temperature goes beyond these thresholds, but how do you set the threshold? By looking at the data over a period of time, and that's typically how a real-time analytics uh, can work. I know I gave a very long-winded answer. Sai Krishna, I hope I was able to answer your question. Excellent. Okay, so some pitfalls to avoid, just as a word of caution. Uh, Please always ensure that you have a proper data strategy. Data strategy doesn't mean that you need to have a big data environment, because a lot of customers will get turned off if you keep saying big data without really understanding it. You don't really need big data for most of the scenarios. You can manage it with your regular uh, databases. Um, Most of the data, especially in an IoT context, will be noise. Okay, so extracting usable content will be difficult, but that's the part of the fun. IoT analytics does not replace the traditional ways of doing things. It augments it. The analytics platform has to be chosen. So some products for you guys to be aware of. If you are purely on the visualization space, you can consider products like Tableau, Power BI, SPSS, or ClickView, or R. These are some of the products which will help you do visualization alone. If you are in the end-to-end analytics, consider products like R, Python, Julia, MATLAB, or SAS, or most famous Excel. 80% of the businesses still do their analytics on Excel. So please don't ignore that. That's the most useful platform. If you are looking at a big data environment or a more solution wise, so there is a company called Databricks which has built a Spark environment. They have built a online studio, a community server or some sort, where you can practice some of the big data technologies like Spark. They give you about 6 GB space for you to experiment. Okay, so that's completely on a big data environment for you to try out. If you are in a business, I guess some of these technologies will come into play. If you are into image analytics, please don't try to build everything from scratch. Google publishes an API, Microsoft has an API, Facebook has an API. Number of companies have got their APIs. You want to do an image recognition, you want to do a face recognition, you want to do an emotion recognition, all of that are already possible. But if you want to build your own custom products, please consider a product. So you need to have a huge big image platform which is significantly larger than your regular big data environment, and then that has to be taken into account, because one image, a 100 by 100 pixel image, when it gets converted into columns in your data, 100 into 100 will be 10,000 columns easily. You add RGB to it, you essentially multiply it by another 3, so that becomes 30,000 columns of pixels. So it can very easily take a whole lot of space there. Okay, so that's to ensure that you have the right analytics platform. Should be predominantly business driven. So a lot of people have artificial reality, augmented reality kind of solutions. They want to have this VR headsets and they want to do some beautiful IoT slash analytics sometimes, if not analytics, just IoT. And you tend to fall in love with that capability of the device, but please keep in mind your business requirement will essentially drive the money. So if it is satisfying a business problem, it is very easy for you to sell that. Please have that. Privacy issue is the last thing. Um, if the devices in an follow certain standards, yes and no, Arshil. So if the devices are of the certain standards in terms of your BIS, IAS, ISO kind of standards, yes. But that is not the end of it. It is not just the whether the device successfully sends the message through to you, or it fails because of whatever reason. That is just part of it. Now, it is a combination of many things. Uh, Cleanup as an activity might be easier. from a sensor device because it is a standard format. It sends you the same set of columns every single time. So you know what it is supposed to be, what it is not supposed to be. And if it is not what it is supposed to be, then you can determine, okay, is this an anomaly or is it a sensor malfunctioning? Maybe the device was reading the correct temperature. It is not supposed to be that. Then that is a cause of concern. Otherwise, it is a device failing. And normally a sensor generated device, the cleanup activity will not be so much. But the issue won't be that. The issue is, what are you going to do with the data? Is the data sufficient enough to help you answer the business question? So a temperature sensor might be a hurdle, might be an important thing to determine whether a truck was opened at a particular point or not. It may give you a clue, but you don't really know whether the truck was in transit at that particular junction or not. Okay, let's say if the truck was traveling and there is a temperature change that you are detecting, it might be contributed to some other external factor, nothing to do with the pilferage happening. It's not that the door was open. Maybe there was something else that was overheating. Maybe the truck was in a very hot, sunny condition. Suddenly, for about an hour before that, it was, maybe there were some cloudy conditions or something like that. So there could be number of reasons because of which that was. So just because your temperature sensor is clean and your data is clean doesn't help you. You need to add additional data. Was the truck in movement when this temperature changed? If it was stationary, then I know, what, something has changed. The truck was parked somewhere, and that will ensure that. But if you don't have that information, then your analysis is going to be incomplete because you don't really know, did the person stop the truck or did the temperature just spike because of some other reason. So you have an inconclusive reaction to that. You don't really know what to make sense out of that. So insufficient data can simply come because we have not thought through all of that. Just implementing a temperature sensor alone may not give you the answer. So I think the inside questions will kind of drive those particular requirements there. So I hope I answered your question, I think Mohammed Arshil. Excellent. Okay. I mean, this is just a last slide, which is basically trying to put things together. With that, we have come to a end of this particular session. I hope it was informative for you folks. And if there are any questions, please do reach out to Axelta. I'm still open for. I know we have overshot the time, but I'm still happy to take up any questions that you may have at this juncture. Yes, I am going to. I have recorded this session. I will be sending this to Axelta site for this to be uploaded. Yeah. Thank you. If there are no further questions, thanks a lot for patiently listening in. And good luck to you all. Thank you. Thank you. Utkarsh, I think all the companies which use IoT essentially have to apply analytics. Without analytics, IoT on its own doesn't help. So some of the examples I've covered in the session today. Okay. All right. Thanks a lot. Bye now.